I want your guys' feedback on how you think your homework went. What do you think? How did that go? Did it go all right? Did you guys struggle? Did anybody have a difficult time? Was it pretty straightforward? It was easy. Was it interesting at all? Or was it just kind of like, this is okay? Like that type of thing? I'm trying to think of some.
An answer.
Do what?
I said unmute yourselves and answer.
Oh yeah. You guys can talk. You definitely can talk. It doesn't have to be an Andrew show. I mean, I like the Andrew show, but you know, if you guys want to talk, that's totally cool.
The part where we had to like put which elements were in the stars was confusing for me because like there were lines on all of them. So it was like.
Yeah. So that was kind of hard, right? And then you had to take the slider. Did you use the slider to kind of bring it over a little bit and then compare which ones like matched up? Yeah, I can imagine that was pretty tough. Anybody else? Anybody else have any difficulties, or did this spontaneously, you know, inspire you to like go out and watch, you know, what is the movie? I can't even think about it now. Did anybody watch any like space themed movies because of this? Did you go see like The Martian, or did you watch like First Contact or something like that? Anything? Anybody do anything like that? No, absolutely not. Just kind of sat around staring at your computer screens. Space Monkey? I don't think I've ever seen that before. I'm gonna have to. Is that on Amazon or something like that? I'll say yes. Awesome. Maybe I'll put that on my list. I was telling people that I'm getting ready to have like my own like little anime fest. I think I'm gonna be watching Howl's Castle and maybe like Ponyo or something like that. So I've never seen it. Space Monkey. If space is in the title, then it probably is a safe bet that that's going to be there. So, all right. Well, that's cool, everybody. Hey, so what I would like for us to take a look at this week, I'm thinking if I should just be like, okay, everybody, today we're going to be talking about, and then just go into that smooth radio DJ voice where we're going to be talking about this and going through like that. And then I'll just watch to see if you fall asleep and if your head just kind of like, boom, you know. So, all right, let me do a screen share. Okay, so today, what I want to do is I've got a couple of videos for us to watch. But then let me pull up the chat so that way I got you on the chat. All right, so what we're going to be looking at today is we're going to be working with something, and I don't know if I've made you guys do this in the past. If you've been with me as a group, then I kind of, maybe I have, maybe I haven't. Do you guys know about this? I'm sure that the Upward Bound, the main people for the Upward Bound are probably sick of me talking about this because I talk about it in like all of my classes, every single one, and I make all of my students do this stuff. Have you guys ever had Tinkercad? Have you guys ever worked with this before? So I'm gonna log out. So this is the website, and in fact, I should probably copy this over and let me edit this real quick. Let me throw this in here. Let me include it right there so that way you have access to that. And then, so Tinkercad is a free modeling system that allows us to work with designs in 3D, and we can export those designs for use in like a 3D printer. So it's kind of cool because it's a free, you don't have to like download any of the information or any of the software to your computer. It all operates up in the cloud. So if I go to sign in, you'll do join now, and it shouldn't cost you anything. If you ever get into that and they're like, you have to put money, no, it shouldn't, you know. So go ahead and enroll yourself. Don't do this whole students join your class because I haven't created a class for you guys. So it just basically be like a single user account. So you can sign in with your Google if you want. So I'm going to use my username and maybe it will remember me. Let me put in my, and then so if you've never done this before, it should load up like a welcome, and it should then run you through a whole bunch of tutorials so that you can then utilize and work with basically how to like manipulate things and work within the system. So you can access that stuff at any time though. If you come to learn, or on this left hand side you'll see this thing that says lessons. And what this does is it basically kind of goes through and shows you how to do things. Now, if you want, I can click on, what is it? Learning the moves. I think this is, can I reset it? Since I've already done it, it's kind of, I don't remember how to reset it. But if you also come up here to learn, you can come through and you can actually see all of their starters on how to like place it, view it, move it, rotate it. Like, you know, even this first one here, where you're talking about place it. You have the instructions here, and they've kind of ghosted it out, right? So it says, see the orange shape on the workplace. That's a hint. Helps you guide where you want to get started. Find the box square in the shapes on the right side of the screen. Left click and drag the box shape into the hint on the workspace. Continue to the next step. So I'm going to come over here. I'm going to grab my box. And I'm going to place it there. Click the next step. Hey, look at this. It's exploding with stars. That lets me know that I've done it correctly, right? So it's kind of like a way for us to work your way through and understanding how to, like, you know, manipulate the space, how to actually work with the material that's there. Okay. But let me show you some of the things that you can do with this. Let me see if I can go home to my thing here. Lesson completed. You can actually go on to the next one, which is kind of cool too. But actually, let me come back to my site. These are some of the things that I've made. So this is actually the cap that I'm using on my webcam right now. So I made this using this, and then I printed it out with my 3D printer. These are some of the things, like I made my sister-in-law a graduation from KU Christmas ornament with this program. And then I printed it out and I gave it to her. We've used these before to hold all of the stain bottles that we actually have in the micro lab. So we made a little ring system that holds all the bottles upright so they don't fall over in the drawers when people open and close them. And then we use the college's 3D printer to print those out. So we actually use those. And just people like have made all kinds of stuff like cell models. This is actually a custom mask system placement that I made for somebody that wanted a 3D printed respirator mask for them. And so I ended up modifying it in there, doing that. I made hubcaps for my car, like inserts for like my car. I mean, you can pretty much do anything that you want using this system. And that's really kind of cool. Oh yeah, and I use this for like my lawnmower and stuff like that. So, oh my God, do I really have 4 pages of stuff? I'm trying to find. And then I also use it to make parts for my 3D printer as well. But let me see if I can't get down to something that's kind of fun. Have you guys ever heard, well, I'm sure you have. We made V-Bucks. We actually used this to kind of, for an Upward Bound project, I think. We made a whole bunch of V-Bucks for you guys in the past. Kind of gave them out as like a token type of thing. So You know, we can do a lot of stuff. And then what's really kind of cool about this stuff too is, let me click on this. This is just a simple model that was made a long time ago. One of the neat things that you can do for Tinkercad is you can actually click on this button here, and it will take your model and it will make it into Minecraft blocks. So you can actually then see what your model would be like in Minecraft style, or if you wanted to build it in Legos, we'll actually Legofy it for you. So that way you can kind of get an idea of like what your model would be like if you actually made it in Legos, right? So it's kind of like a lot of fun. There's like, you can mess around with a lot of the different shapes. You can build a lot of stuff. I mean, now this house kind of sucks because it's all the same. It's not really split up or anything like that. In which I think if I highlight it, then of course, you know, are you gonna work now that I'm under pressure to show you stuff? Okay. What we can do, and I think if I did it like this, I think now it should make all those individual pieces out of different colors. Yeah. So that kind of gives you a different type of setup. But what I'm saying is that this is a way for us to make 3D models in space. So if I want to use, you know, and let me just go back here real quick. And it should auto save all of your work. So whatever you're working on, it should auto save as you're going through it. If I want to make a new design, I'm going to come here and create new design. If I wanted to make a model of the Earth, I could use this sphere as a model. But then now I see that I have to think about my dimensions in 3 dimensions, right? Like it has to have a certain shape, certain functions, stuff like that. I'm actually going to undo that. And so there are various ways that you can do this. Now, if I wanted to make this as the Earth, and I wanted to bring this in as the moon, what's the problem there?
They look like the same size.
Mm-hmm. Now, would that be correct? Is that something that I'd want to do? No, right? And so I have to figure out how big do I have to make the Earth relative to how big I have to make the moon. Now, you're not going to be able to model on a scale of 1-to-1 for the Earth, right? Because you'd just be scrolling out for forever in that sense. So you have to figure out a way that you can take the dimensions of the Earth and of the moon, and you have to scale them so that they would be approximately equal when viewed through Tinkercad. And so that's what we're trying to focus on a little bit this time around, is that we're working with information in 3 dimensions, right? So when we think of a classical type of graph, we've got an x-axis and we have y-axis. So we have x, we've got y, and now we're incorporating a z dimension, a 3rd dimension. So you have x, y, and z for the depth. And so we could make this 2D. Maybe that might be something that you want to start with. Could we do that? Yeah, you could actually just pull a cylinder over here and you could make this, you could actually scale this down so that it was, let me see, if I click on this, I could make this a scale of 1. And so now when I viewed it from this direction, I could have the circumference of the Earth versus the circumference of the moon. I could have something like that. You know, I'm just asking for models, right? That's all that I'm asking for. If I come back over here to this for homework for week 2 for you guys, I said I would like a model built to scale, whatever scale you'd like. When it says built to scale, what I mean how should I reword that? I'll have to think about how to reword that here. Built to scale in class discussion, what we're talking about today, like between the Earth and the moon. I want it to be approximate scaling. And then also I'd like one of the inner planets, one of the outer planets, and then basically one of our solar system. Could you do it? Could you do that? Could you make those 4 different models with Tinkercad? That's what I'm asking you to do. And so I've given you the link for Tinkercad there. And then once you kind of get a little bit familiar with that, we kind of get into this concept of, if all that I'm doing right now, and really I can make something super simple, right? So let me delete this here. Let me delete this here. And right now it's kind of hogging up a lot of the resources on my computer because this is web-based and I'm also streaming with you guys. So my computer, my internet connection is kind of being maxed out right now. So that's why it's working so slowly in that sense. But if I wanted to do something like this, I could literally have, oh, and I think I'm actually lifting it. I don't want to do that. But what I could be doing is that I literally could be like, all right, well, here's the sun. No, this isn't the scale, but I could be like, all right, here's Mercury. This is distance-wise would be appropriate. And then I could say, all right, well then what's next? All right, so you're gonna go, here's Venus. And then you're gonna be like, all right, so then here's, you know, maybe Earth is like out here, you know. And then you're like, maybe Mars would be out there. You'd have to figure it out so that you could represent that on the Tinkercad. And so I'm giving you some examples as to what you could potentially do. I don't like to put a lot of restrictions on my students, and that tends to infuriate some of my students. Not scale to life, but scale in comparison to other models. And yes, that's what I'm going for. And it's right on the tip of my tongue how I can think about this. But I want you to, I'm going to give you a lot of room on this to kind of choose what you want to do. If you want to do a two-dimensional, kind of like what I've shown you here, where we're just kind of concerned about the X and the Y, you can do that. If you want to make it a three-dimensional sphere and you want the spheres to basically be scaled into the appropriate sizes amongst the planets and the sun, you could do that as well. You know, it's kind of up to you. Don't overthink it. That tends to be the problem for a lot of people on this, is overthinking. Don't overthink it, all right? And so that's the first part. It's just, I'm going to use my knowledge. I'm going to go out there. I'm going to Google. I'm going to figure out, well, you know, if the Earth is this big and the moon is this big, what kind of scale is that? You know, is it a 2-to-1? Is it a 1 to 0.005? Like, it forces you to start working with numbers a little bit and understanding, you know, okay, if I'm going to represent the Earth as a 1-inch or a 10-millimeter sphere, how big does the moon have to be? And you might run into problems. You might be like, I can barely see the moon. That's how big it's going to be. And so you might have to adjust. You might have to rethink your plan as you're going through it. And that's fine. This is more of an exploratory assignment. And it's meant, on some level, I kind of hope you get a little bit frustrated with this assignment. You know, I really do, because it's going to make you kind of have to go back and think about things and how can I show it in such a way that I want to show it, right? So, you know, and I'm sure that I'll probably have some students that give me like a detailed, like, Earth, like they're like, I spent 5 hours making the Earth to scale so it looks cool, you know. Like, I mean, if you want to do that, that's fine, but what I'm telling you though is that I just want something that's appropriate in size, relative size, right? Relative size and scale to the other planets, into the moon. Now, when you actually make the model of the inner planets and then the outer planets in the solar system, you don't have to include the moon. You can just include the Earth. You don't have to worry about including the moon on that. And so I would like you to use Tinkercad on this. All right, I want you to get familiar with that. And why? Because the next thing that we're looking at is, I want you to think about, okay, just understanding that the planets have different sizes compared to each other is one thing. But what about their relative positions in space? Now, this one forces you to think about things in 3 dimensions. And so I've given you this link here. Okay. I've given you this link here. Let me see if I can. And this gives you the inner planets. Okay. And actually, if you zoom out, it will give you the other planets as well. fact, if I go out farther, this gives you, in fact, you might actually want to kind of start here to help you kind of get a sense of distance if you want. You can take a look at this. But this kind of gives you the positions of the planets, where they are for a particular date in time. So who's got a date that we can look at? You guys sports fans? What are you fans of? Nobody wants to go to when the Chiefs won the Super Bowl? I got you. In fact, I don't even know what date that would be. I don't even know when the Super Bowl is. I think most people, don't they hold the Super Bowl at like a set time, like Thanksgiving or something like that? Like it's always the same date every year or something. Who's got a date for me? Who's got something for me? Hmm. How about the first day of Upward Bound? When did Upward Bound start? When was that? When did our class meet for the first time? That was what? July. Let me come back and look at my calendar. I'm supposed to know these things, right? Let's look at this. The 3rd. Okay. So if we come back to July 3rd, notice how things shift. And let me zoom in just a little bit here. So I'm going to be looking at the inner planets. Let's go back 1 year ago. There's different positions. What about 2 years ago? 3 years? 4 years? Did you guys ever watch Scooby-Doo Mystery Incorporated? The latest reboot where they're having to get the planetary discs and stuff like that? You never did? Oh my God, you guys got to watch that. I think it's on Netflix right now. It's fantastic. So sad that they canceled it. In one of their story arcs, they were talking about there was a time when all of the planets were going to come into alignment between the sun, Mercury, Venus, Earth, Mars. Like there was like going to basically be a setup where all of them were going to be on exactly one side. And it kind of like, you kind of get the concept. Where is it? Kind of like this, but they were literally supposed to all be like lined up, and that was supposed to be some big significant thing for them, right? So when we think about the solar system, we have to understand that it's dynamic. And so one of the cool things, I've seen these on Etsy shops before, and I've seen them for various different things, but basically you can take a date and like take, for example, I'm going to choose this date because this is my birthday. And then this, or is it? I like to mess with everybody. So, you know, is this date right here, this shows where the planets are. And so I've seen Etsy shops, Etsy or however you say it, where they've literally made models, where they've got like a pendant where you'd have something that you'd wear with like a special date in time and history for stuff. So like what I'm asking you to do then is, if we come back here to this, I want you to say, well, how could you find the positions of the planets for a specific date, and how could you model that for 3D printing? So take, for example, you know, if I want to use this as my birthday date, how can I make a model in Tinkercad of something that I could print? And so where's my Tinkercad at? Did I get rid of Tinkercad? I hope I didn't close it. Maybe I did. Oh, there it is. If I wanted to make a model of that, how can I represent it? You know, I think one of the easier ways that I've seen was that they literally just had something like that, and then they just put dots, holes basically around here to represent where the planets actually were, or maybe like an indentation in the line. And so because when you print with a 3D printer, printing something that's three-dimensional like a sphere is going to be kind of hard, you know. And so what I want you guys to do, and maybe this is too much for just this first week, maybe what you need to do is get comfortable with Tinkercad. Maybe you just need to get comfortable with Tinkercad first and just work on making these types of models. So that way you kind of get some knowledge of the Tinkercad stuff. And then you can explore this idea of, you know, is there a date that you'd like to model? And then how could we print that out? And I think, let me see if I can't just Google this. What I'm thinking is they kind of had, what is it? Let's see, planets date pendant. Maybe that's what I'm thinking. Something like this. Yeah. This is kind of cool. This is along the same lines as what I was thinking. So this would actually be something that would be relatively easy to print with a 3D printer. So what it is basically it's just a pendant, right? And it literally has lines that are etched in it. And then it has dots that represent where the planets are for a particular date. And so we can make stuff like this, and you could print the date on the back of it as like a recessed thing. And you literally then can print this out. I could start printing them out here. And by the time that we get done with Upward Bound, I can send it to you. So you can kind of see that printed. Now, whatever date you pick is up to you. And please don't keep the significance to yourself. It's not necessarily something that we could just, I think that, you know, keep it to yourself in that sense, unless you want to share it with your friends. Like, please don't just dump that information into the class channel in the chat or something like that. You know, but, you know, why don't you pick a date that's significant to you? So then that way you can, where the planets are, and then we can work on actually once you get your model finalized, I'll start printing those out for you guys. So that way, by the time Upward Bound gets done, then you can have that, and you can use it as a pendant. You could use it as a, I mean, you could maybe use it as like a coaster for your drink if you wanted to, you know, something like that. I don't know, whatever you guys want to do. Whew. I swear I'm not dying. Just went down the wrong pipe there. So what I would like for you guys to do is basically make your own model. Man, oh man. And then we can print it out, and you can actually watch them printed. I've got the YouTube channel, so you can see the stuff getting printed out. And then because it will have the date on it, then that would be your identifier. So you just give me your date and your model, and then that way I can make sure to get it back to you. So that's really kind of what I'm hoping for, is to be able to like do something cool like that. And so what I'd like you to focus on though first is I'd like you to get familiar with Tinkercad, and I'd like you to make these models first, okay? And then what I'd like you to do is then we can start looking at this whole idea of, well, where's the positions and how would you actually show that? And could I make something that was cool, but then yet was totally 3D printable? So that you can use that site for that. And then here's just a couple of videos real quick that I wanted to watch. I want to watch at least this first one. I want to watch this first one. It gives you just like a brief overview. This is an ad. Let's see if we can. I don't want to go to Disney Plus.
Hi, it's Paul Anderson, and this is Disciplinary Core Idea ESS 1B. It's on the Earth and the solar system. The solar system is not only the sun and the Earth, but it's everything that orbits around the sun. So it's going to be all the planets from Mercury to Neptune. It's going to be the dwarf planets like Pluto. It's going to be the moons around those planets. It's going to be asteroids. It's going to be everything that orbits around the sun. Why is everything orbiting around the sun? It's because of the huge amount of gravity or gravitational force of the sun. And that gravity gravity led to the formation of the solar system as well. So we think it used to be just a massive disk made up of dust, and gravity pulled those dust particles together. They became bigger and bigger and bigger, eventually formed the sun at the center and the planets around that. And they're still in orbit around the sun. Now, we used to think that the Earth was at the center of the solar system, but a number of scientists like Galileo, Tycho Brahe, and Kepler allowed us to understand what's really going on. And Kepler's laws explain how the solar system works. He basically had 3 laws. The first one is that the orbits of planets around the sun are elliptical. And the second law is kind of drawn right here. The idea is that in a given period of time, the objects are going to move and sweep out an equal area over time. And so when you're closer, so a planet is going to kind of move around the Earth like this. As it gets closer to the sun, it's actually going to go faster, and it's going to go slower when it's further away. Another scientist, Sir Isaac Newton, used the work of Kepler to come up with a better model of what's going on in the solar system and predicting the motions of objects in the sky. And so what are some things that we can use this current model to predict? We can use it to predict how the planets might move through the sky. And so everything that you see in the night sky is not necessarily a star, it could be a planet. And these planets show something called retrograde motion. So they'll move backwards almost in the night sky. Why is that? It's because we're either passing them or they're passing us. And you can figure out other things like Venus, which is inside of us. We tend to only see it in the morning and at night, and that's because we're only going to see that because it's on the inside of our orbit. We can understand how eclipses work. This is a lunar eclipse, and why we go through phases. So why the moon go?
So I wanted to, I kind of wanted to make sure that you guys knew that when we talk about graphs and we talk about data, right? When we start exploring the solar system, this concept of those 3 dimensions and then how it relates to us is important because we're moving through the whole thing too. So it's complexity built upon complexity, right? So this is really what he's talking about is we're already down like inception level 3 or inception level 4. And so I want you guys just to be aware of that because it's not just I'm going to look at planets on a 2-dimensional poster and they're stuck there. They're moving, we're moving, and then that brings about different types of effects. Like we have real things that we can see and measure when that happens.
Go through phases during the course of a month, we can understand all of those using this simple model that was developed by scientists. Now, everything isn't static and doesn't continue like that forever. In fact, even the Earth, as it spins, is gradually slowing down over time. The Earth is not straight up and down in relation to the sun. It's slightly tilted, and that tilt changes over time. And so if we look at, this is measuring from today and thousands of years in the past and in the future, that angle is actually going to tilt. It's going to wobble. And these ellipses are going to vary over time. And so all of these variations can lead to changes over time. And so the ice ages are actually caused by changes in not only the orbit of the Earth, but its tilt as well. And you can see those over time. This model allows us to understand how the seasons work. And so if that axis, if I were to draw it right here, sometimes the axis is kind of tilted towards the sun, and that would be during a time of summer, and sometimes it's tilted away, like in winter. And so in our winter in the northern hemisphere, we're actually closer to the sun than we are during the summer. But since we're tilted towards the sun in the summer, we're going to get more direct light. And that's why our summer is going to be winter in the southern hemisphere. And so how do you teach all of this to our students? Well, at the beginning, in the early elementary grades, you want them observing, and you want them making descriptions and finally making predictions. And so a great way to start doing this and understanding how the Earth moves in the solar system is just looking at sunset and sunrise. So what time is the sun rising and what time is it setting? And so you could keep track of that during the year, and what you would Neptune.
So what I'd like to share with you too is just a couple of really cool videos here. Let me show you. Let's go over here. So when you go outside and you look up at the night sky, it's going to be different where you are versus relative if you're on the North Pole or the South Pole. So this is actually a time-lapse video of what it looks like if you're on the ends of the polar regions for the Earth when it comes to this. This is actually pretty sweet. The music is really creepy. I didn't expect the creepy music, but what you can see is you have basically rotation around, you know, set points of where we are. Now there's also moving stars of the southern hemisphere. You know, another thing too is that this kind of has consequences for, what is it? Sun never setting in Alaska. Depending on where you're at on the planet, because of the tilt of the planet, we also have effects like this.
To the Empress of Russia.
If the Emperor dies, Russia goes to the Empress.
A woman.
I could kill you. You are bad.
Why is this 5 minutes long?
And
Is this not the video? Oh God, here it is. Sorry, everybody. So can you imagine being on either one of the tips of the planet and then experiencing 24 hours of daylight for a certain period of time in the season of the Earth?
That
You know?
sounds awful.
This sounds awful. You know, they've got a really, what's the creepy movie? Oh, it's super gory. What is it, 30 Days of Night? It's about
Yeah,
vampires.
That is
about
good.
Yeah, they take over a small town in the upper regions of Alaska, because just when we have this idea of, you know, having time periods where it's always going to be light, then there will also be time periods that are associated with a continued darkness type of thing. And so I think that one's called 30 Days of Night, but it is ridiculously gory. Like if you you don't like gore whatsoever, do not watch that film. But so even in our planet, right? So when we think about, all right, well, I'm here in Kansas, I'm used to day and night, and that's how it is, right? Well, if you go to different parts of the planet, you're going to experience different types of things. And so that really comes back to that idea of, where are we? Where's the set point? And how do I relate to everything else? Because I'm moving on the planet is moving, and it's moving in relationship to the sun. Now, is the sun actually even set in a particular spot or a particular place? Is the sun constant? Do we know anything about that? Have we ever thought about that? So the sun itself seems like a set point for our solar system, but our solar system is actually in the arm of the Milky Way galaxy that's rotating around a supermassive black hole that's in the center of that. And that supermassive black hole is probably rotating around another superstructure that's associated with that. And so everything is moving constantly. So how does that relate back to this whole idea of the graph? So hopefully I didn't break your brain today. Hopefully you didn't have it just go like critical error and just shut down. What I want you to think about, but that's what I want you to be thinking about, is the relative position of where we are, and then how do we represent things like that in two-dimensional space, in three-dimensional space. You know, that's what I want you thinking about. So if I come back over here, to this share. You know, take a look at this first part. Jump on Tinkercad, take a look at, see about making these models up. By the time that we come back for lab next week, I'm going to take a look at your stuff, what you did for homework wise for this last week, and I want you to be working on these models. And like I said, you can jump down to this stuff here. You can actually, you know, use this to kind of get an idea for the date that you're interested in, and then make it. You can start working on making on something in Tinkercad if you want. And then I can take those designs and I'll start printing them out. I've got some colors. I've got different colors of filament. So I might be able to get you to select whatever you want for that. And then I can send it to you by the end of the summer session for up or down. So you'll have something cool. And then that's pretty much all that I got for today. Anybody got any questions? So it's about modeling. So get on that Tinkercad, get to work, you know, exploring and creating and seeing if you can come up with some kind of like a scaled representation for those things that I've asked you to do. And remember, if it's impossible, you're probably thinking about it too hard. You know, try to keep it simple. You guys ever heard of the acronym KISS? All right, so KISS usually stands for keep it simple, stupid, but ain't nobody stupid in here. So we're gonna change that to say keep it simple, silly. All right, don't try to make it super complex. Try to keep it simple. Keep it simple, silly. All right. Okay, everybody. If you don't have any questions, I will let you go. And hit me up if you do. I'll be dropping into some of your guys's they're not office hours. What are they? Little homework help?
Like study hall.
Study hall. That's the word I'm looking for. I'll be dropping into study hall this week to see if you guys needed help with any of your modeling stuff or anything like that. So give it a try. It's going to be awkward and you might be like, I hate this. Well, give it a try. Work through it because you know, there's some really cool applications that you can use for this stuff later on too. So, all right, everybody. Thank you so much for being here today.
Okay.